Hello, my name is Ardi, and let's solve assessment problem 5.1 from Nilsson and Riedel's book. So the question is, assume that the op-amp in the circuit shown is ideal. Calculate V0 for some values and specify the range of Vs required to avoid amplifier saturation. Okay, let's do exactly that, and let's take a note here that we have an ideal op-amp. So we'll have ideal op-amp. Okay, so let's name this node here as node VA and this node here as node VB. Okay, remember that we have an ideal op-amp. VA will equal to VB, and also the current that goes into the op-amp, let's name this as IA, and let's name this as IB. That will be 0. So the second condition is IA is equal to IB, and that will equal to 0. This is the condition of an ideal op-amp. Okay, so now maybe let's do a KCL at VA. So we will have this current here. Let's assume this current here. We know that VB is connected to the ground, so the ground here has the voltage of 0 volt, right? So that means that VB is equal to 0 volt. Okay, and because we have an ideal op-amp, VA is equal to VB. That means that VA is also 0 volt. Okay, and now let's do KCL at node VA. KCL at node VA. KCL said that the sum of the current that goes in will equal to the current that goes out. And the only current that goes in is this one. But then that one can be calculated by using Vs minus Va. So we will have Vs minus Va divided by the resistance between them. That will be 16. And all the other currents going out. So we will have this current here, IA. But IA goes into the op-amp. The current that goes into the op-amp is this one, so I will have a 0. And then plus VA minus V0 here. So I will have V0 divided by the resistance between them, which is 80. But remember that VA is 0 volt, so we will have Vs over 16, because Vs minus 0 is just Vs. And then this one will be minus V0 divided by 80. Okay, so now we can rewrite this as V0 is equal to, I think, minus Vs here and minus 80 divided by 16. I think we will have minus 5 Vs. Okay, now let's put the values that the question asks us. Okay, let's see if Vs is 0.4. Okay, Vs is 0.4. What is V0? V0 is minus 5 Vs. So I will have minus 5 multiplied by 0.4. That will be minus 2 volt. Okay, V0 is equal to minus 2 volt. And then for 2.0, okay, let's see. 2.0. And I think V0 is just 5 multiplied by 2. That will be 10. But we will have negative sign, so I will have minus 10 volt. Okay, and I think Vs is equal to 3.5. 3.5. And then what is 3.5? V0 is equal to minus 3.5 multiplied by 5. Minus 3.5 multiplied by 5. that will be minus 17.5. Minus 17.5. It should be, but remember that here we will have minus 15 as the maximum. So we will have minus 15. So we'll have V0 is equal to minus 15 volt. Okay, now let's move on to this minus 0.6. Okay, Vs is equal to minus 0.6. And what is V0? V0 will be 5 multiplied by 0.6. That will be 3 volt, right? 3 volt. Okay. And now what else? Vs is equal to minus 1.6. Minus 1.6. That will be V0 is equal to 5 multiplied by 1.6 is just 8 volt. Yeah, volt. And then when Vs is 2.4, Vs is 2.4, we will have V0 here as 2.4 multiplied by 5. That will be 12 volt. However, we will have the maximum value here. That will be 10 volt. Okay, so the output will be V0 is equal to 10 volt, not 12. So remember, if it's exceed the maximum or minimum, this is not the answer. The answer is just the maximum and the minimum. Okay, and that is for the question A. Maybe let's label that. And now our slide is full. Maybe let's clean that up and solve problem B. Okay, now let's solve problem B. Remember that V0 has to be between minus 15 and 10. So I'll have minus 15 is less than or equal than V0. And then less than or equal than 10. Okay, let's plug that V0 is equal to minus 5 Vs. So I'll have minus 15 greater than minus 5 Vs. And then less than 10. Okay, now we divide both sides by minus 5. Remember, if we divide an inequality by negative number, we need to flip the sign. So we will have 3 here, but then the sign will be that, and this will be Vs, and that will be minus 2. Or to make things tidier, that will be minus 2 is less than Vs and is less than 3, which is the answer for problem B. And I think that's all for question 5.1. And let me know if I made any mistakes in the calculation. See you in the next video. Bye-bye.